throughout Indian continent. So we are working and we develop many technologies. So I would like to share these technologies, as these are the challenges what we are having behind us. One is the population growth, which is very rapid, industrialization, but inadequate infrastructure and housing. That's a major issue which is always standing behind us. And moreover, if you see the population trend, how it is rising every year, both in the urban as well as rural sector, both the places, the population growth in India is very high. And it is estimated around 60 crore will be the population in the urban area, around 40, remaining the 40 crores will be in the rural area. So this much of the population, presently it is focused, and the remaining will be in the semi-urban. As a current trend, it is 130 crores of population, that's we know, and it may be raised 15 to 20% within the coming another 10 years. Moreover, the population in the slum population in the urban area, it is keep on rising. That is one more fact what has to be very concerned because of the movement of people from rural to urban for their livelihood. So these are some of the major issues. So focusing this one, another one issue always we are very concerned about this one, the conventional brick wall construction. So what is the priority for the clay? Whether it is a renewable source or it's a non-renewable source. There's another one more big question always it is standing behind us. So generally what we are considering is the clay is the basic material and it is meant for agricultural activities, but the continuous extraction of the clay for fabricating the clay bricks will be a problem in future, definitely. Another one more is the deforestation. So this combined effect always we are keen and we are trying to develop a alternative technology which can totally or partially avoid the clay usage. And moreover, our technologies, what we are focusing is to be a green and it's also be a sustainable and it has to satisfy the renewable norms and also the renewable norms. So this is what are the challenges and what are the scopes and aims what we are keeping with us for developing the technology. So in this aspect, we found that they were not the technology in precast construction technology. We are finding a lot of future for the construction industry, both in the residential building construction or commercial building construction. So why we actually need this precast construction? So one of the things is it is the technology for the future, and another one is we are suffering a lot with the labor and the construction material and the rising cost of the materials. This is another one more factor what we are facing a problem. And also the unplanned construction practices, what we are using current days, it is waste a lot of materials and natural resources, so which is here a key concern. Similar way, the conventional construction normally will disturb the movement of the vehicles or the traffic inconvenience and the environmental disturbance. These are some of the factors what we are seeing in the regular construction activity. So we are feeling that this precast construction, that's also in the affordable construction practices are key for the future development of the country. So how we can achieve? So these are some of the points what we are seeing this can be achieved by this way. So we can plan for because the precast construction means it is always a regular pattern and it also we are using technology for the mass production. So normally this will have the most saving of the money and materials, and we can incorporate the technology advancements, whatever we are having with us, whether it's with the computational methods or the advanced material construction materials what we were developing and using, and how we can use the natural resources. So everything we can program in a confined way so that we can get a very better product from the prefabrication. So this is what we were seeing, this precast technology is the practical solution for the infra development. and which is having the very high quality control, because most probably this will be made at a factory. So factory, the production means the quality control is very easier way compared to the conventional one. So we can get a very better quality control. And moreover, we can optimize the usage of material and labor, which leads to the reduction of the requirement. So, moreover, this prefabrication or cast construction normally reduce the undesirable the environmental impacts, like the pollution. Pollution may be a sound pollution, or it may be a dust pollution, whatever may be the case. It is reducing the overall the pollution factor which is happening in the construction. So normally the prefabrication nowadays, it is possible to develop the building components from foundation to the topmost roof, and the lintels to facades, and then staircases, everything we can prefabricate, and then we can assemble, or we can make use of these components at the site. So this is the very big advantages what is we are behind us. If you can capitalize these advancements, we can get a very better production controls. The prefabrication, or precast, which is not a very new to Indian continent, considering the Indian continent, more than 1,000 years or 1,000 years of practices, the Indian continent is very keen to develop the prefabricated construction using this tools. So more than thousands and thousands of monumental structures which are existing in and around us showcase the ability for the prefabrication construction. As a current scenario, what we are seeing is nowadays the Indian perspective itself, it is focusing on the development of precast construction, and the precast construction, it may be only the superstructure or including substructure and superstructure. Everything nowadays it's pre-planned, and we are doing the develop the technology. So these are some of the basic codes we should be very key, and we should be very thorough for implementing any technology or developing the technology. So one is the IS-456, as you know that it's very important basic to us, and then the relevant to the prefabrication, including the prefab construction. So IS-15916 and 15917, and then the for construction of large wall panels, that is prefabricated large panels, we can go for IS-1144. So these are some of the codes. These are all very important to know whatever the points given the code. So in all this prefabrication construction, a few things we can concentrate separately, because it is having the very huge potential for saving the cost as well as improving the quality of the construction. So one is the roof. So normally the roof which is constructed in the commercial construction, it exploits around 30 to 40% of the steel. And if you consider the cost, it is around 15 to 25% of the cost is mainly for the roof development. So if you can develop the technology which can contribute at least for this closing roofs, which can save a lot of resources as well as the initial fund spending. Normally, these two-way slabs you are very familiar in the two-way slabs. Normally, the one-way slab action is normally this preferred construction practice in the industry nowadays. But the two-way slab is having a very good scope, as well as it is having a better economy, as well as the road distribution factors, considering the two-way slab action. The prefabrication industry, now we are concentrating development of the two-way slab construction that we will see in the later on. So this is the pattern of load transmissions. So now I'm going to deliver 4 technologies what we were developed focusing on the only the rural areas or semi-urban areas or urban areas. We have developed many technologies. In these many technologies, I'm going to present the 4 technologies what we developed for develop the technologies for the rural implementation. So normally the porous cement, which is a good material composition, which is having good scope for the future construction practice. It is a composite material. As you know, this is the refined mesh with the mortar, which is combined together, and it is trying to act together rather than the separate steel and separate concrete what we were designing in the normalized physics. This is totally a different way it is behaving. It is like a single entity it is behaving. Normally, if you're comparing with the concrete RC structure or a plain concrete structure, whatever may be the thing, if you're considering this porous cement, which is normally it will have the more load to the strength to sulfate ratio. So normally this porous cement is coming under the very thin elements. With thin elements having the enormous post buckling behavior, the post buckling behavior contributes a lot for the strength and load carrying capacity. So why cover is provided? So when you are coming to the concrete, the reinforced concrete, normally the cover which is playing a major role. If you take a regular reinforced concrete structure, what is the cover and why it is provided? So in what ways we can achieve the proper cover? Because cover is the very key parameter for the reinforced concrete system. So we have to ensure that a proper cover which is provided using a cover blocks and proper protection, it protects the reinforcement from the corrosion. So quality of the concrete normally it depends on what is the cover thickness you have provided for the reinforced concrete system. So what is the minimum and maximum cement we can use for the regular construction practices? So because I'm going to violate these things, whatever I am telling now in future slides. So that's why the regular code provisions, whatever are given in the IS 456, I'm just representing the things for understanding. So normally the 300 kg of cement will be the minimum cement which is recommended, and the maximum cement is 450 kg per meter cube, and with a class that is excluding the fly ash or ground granulated blast furnace, that is fly ash or VGBS is excluded from that quantity. So that is the one key factor which is a very much useful thing for developing the corrosion. So this is the maximum cement content 450 kg per meter cube. It should be used for any construction plant. That's what I said. If you considering the cement is having the chemical composition of tricalcium silicate, dicalcium silicate, calcium, tricalcium aluminate, fluoride. These are all the composition of this cement. Basic the oxides, but it's available in the cement, which is used for the development of the characters. So this is the general hydration, the chemical reaction, what is happening when you are adding water with the cement, that is water, cement with water. So normally this will be the PSHL, normally what we were calling as a binder property. And this quantity is normally around 45 to 60% will be the quantity. So the remaining after the reaction, what we were getting is the calcium hydroxide. The calcium hydroxide, this is the very key chemical property which can make the concrete durable. So this makes the concrete is maintains the alkalinity and pH is maintained around 12.5 to 13.5. This is the key factor which protects the river from the corrosion. So that meaning, what's the meaning is, till the concrete is in the alkaline state, it can protect the steel. When it is become the acidic nature, and then the steel starts to corrode, and then it will be like accelerated corrosion, and it quickly lost its properties. So this is the key factor. But what is the percentage? Normally we record to maintain this pH is around 10 to 15%. Around 13% normally we will considering. The 13% of the presence of the calcium hydroxide can keep the pH around 4.5 to 13.5. So remaining the 7% we can effectively utilize. In that way, for developing the porous cement, we are minimizing, that is, we are minimizing the cement content and less than 450 kg per meter cube, and we are utilizing the pozzolanic material. So why we are using the pozzolanic material is this is the pozzolanic materials which react with the calcium hydroxide in the water, which is giving again a pH. So this way we can utilize around 6 to 7% of the calcium hydroxide for developing the pH itself. The overall, the system gives a denser medium, as well as it will not permit to enter the chlorine or carbon dioxide, which normally initiate the corrosion of steel. So this is the typical representation of the life model for steel in concrete. Normally this is the initiation period. Still initiation of corrosion, the steel will be very strong enough. Once the corrosion is spotted, so that will be a very fast and it is accelerated corrosion. And the TP, now generally this is depends on the availability of the oxygen and availability of the water and what is the OH concentration. So normally the OH, the calcium hydroxide concentration is very high, then the corrosion will be controlled. If there is a reduction of the calcium hydroxide concentration, then there will be a faster corrosion happen. So this is the way how the steel is getting corroded, and one is called there is two reactions normally which is happening in this corrosion aspect. One is anodic reaction, and second one is a cathodic reaction. In the anodic reaction, the steel which is react with water and releases the one electron. That electron travels and then which is react again combining with the any water molecules and the oxygen which is available with the intermedium of the concrete, and again it will the OH. So this way, this anodic and cathodic, which causes the corrosion aspect. So tree diagram for corrosion steel and where it starts. One is the carbonization with the carbon dioxide which penetrates inside the concrete medium, and then that will be react with the calcium hydroxide, and it's making the alkalic nature of the concrete into acidic nature. A similar way, chlorine which enters into the concrete and which reacts with the calcium hydroxide, and then it makes the alkalinity to acidity. So in the both way, what we are seeing is the carbon dioxide or the chlorine, which is not directly having the impact to the concrete. Only it is a react with the calcium hydroxide. Once the calcium hydroxide is, that is called normally passive protection layer. The passive, once the passive protection layer is breaking down, then the corrosion starts. So this way, this carbon dioxide or chlorine, which is contributing for the corrosion developments. So when you see the corrosion aspect, so generally the FP which represents the reinforcement. So this is the different stages of different chemical composition of the iron, which is reacting with water and oxygen, which creates different composition. So if you see this one, and this is the initially what the volume of the diameter of the rod which you are keeping here will be increasing 2 times or 3 times or 4 times up to 7 times it is increasing the diameter. So this way only the increasing the diameter of rod which creates the initial stresses around the steel, and that breaks the concrete. So if the concrete is having sufficient strength to hold together, or any mechanism, external mechanism which is available to hold together, then the corrosion will be coming down. Otherwise, it will break down once the breaks are created in the concrete, the structures are created in the concrete, which permits more water, that is H2O and the oxygen enter into the concrete medium. So it is accelerate the corrosion. As a result, what we are seeing is it's a very faster corrosion and the life of the structure will be coming down. So these are the key factors what we are seeing, how the cementitious compositions are contributing for controlling the durability. Also, how the system, as a system, the steel, it can protect itself for the corrosion. So from the basic instincts of the material characterization, what we are found is cement content. If you are having more cement content, and there will be more calcium hydroxide. And if there is a concrete is very dense, then it will not permit to enter any water or any the oxygen. So this way we can control. One is we are keeping the passive layer is enough, and second one is we are keeping the density is very high, so that we are just protecting the composite, concrete composite. So similar way, the calcium hydroxide or the oxides. These are all the chemicals which are protecting the steel as it becomes a passive layer, and which compensate and protecting the steel. So similar way, if you can control carbon dioxide and chloride diffusion, which normally reacts with the calcium hydroxide, then if you have the control, then it cannot, that is, the corrosion cannot start, or the durability of the structure will be very, very high. So if you use galvanized iron, then the galvanized iron will be the compensating agent which reduces the corrosion. And similar way, a smaller diameter of wires if you can use, then diameter of the wire is very small, like 1.25 mm or 2 mm wires. So this wires itself having very smaller diameter, when you are having the possibility of corrosion, the volumetric increase will be trying to bulge. But the concrete tensile strength, what is having itself with the concrete, which binds, it will not permit to break that its own surface. So this way, when you are using a smaller diameter, you can control the corrosion. So another one way, what we can do is we can use a closer mesh and then denser medium composition, which confines and makes the product is non-corrosive. So now I highlighted what are the positive and negative senses what we can decide for the better durability and then strength aspects. Now come to a ferrocement. So in the ferrocement, these aspects we are effectively utilizing. That's why the ferrocement is the non-corrosive or high ductile material, because of we are combining all these characterizations together, and then we are effectively utilizing. Now come to a strength aspect. When you come to a ferrocement panels, it is a very thin element. So if you are applying a compression force, then it will take a compression force till it start to reaching the critical stress value. Once the critical stress value is reaching, because of the thinness section, it is buckling. So this way, when the plate start to buckle, then the post-buckling strength will be reaching, and then which is giving more strength compared to the normal what is we are designing in the plain concrete or RC concrete. So we are developing many technologies focusing on the many applications, because of few of the applications. And this is a typical test what we carried out to check whether the post-buckling phenomena is happening in the ferrocement or not. We developed a global mix so that we can go for the single casting of the ferrocement panels. So normally in the earlier period, what they did is they will go for plastering with the high-skilled mason. So now the availability of high-skilled mason is very rare, and it is very difficult to get the people like get a good finish and then compacted in ferrocement medium. So the alternative one, what we decided is we can go for a single casting of ferrocement. So this is the way we developed a mix which can flow into the mold, and this is the final system what we developed. This is the ferrocement with the ribbed edges, and every 1 meter we are proposed to give a rib, so that the each bay will act as a single that is individual panel. So that what we are trying here is we are trying to avoid the global buckling. We are trying to convert the panels. It can go into the non-global buckling. So we develop different technologies, and these are the technologies we developed with precast engineering for the service core units, and everything will be cast at the site and then assembled in the field. So this way what we develop, and within 2 hours or 3 hours we can assemble, we can utilize this service core units for the public use. So similar way we develop many format, because the cost is a key factor for Indian contest. So for scattering to the different the demand what is available in the field based on the affordability of the people, we develop many technologies. So the technology what earlier we developed is coming around 20,000 rupees or 25,000 rupees. We transport this technology by a partially superstructure and partially a substructure system, so that the cost is coming down around 10,000 rupees. So these are different technologies what we developed using ferrocement. And the latest one what we develop, we are keep on developing the technologies, because the simplicity and ruggedness and how we are implementing the technology into the field, and how we see it is to implement in the field, and then what is the requirement of machineries. So these are the things are normally governs for the any precast product implementation. So this is the one technology what we developed. This it's no need of any machineries or any equipments, so that we can simply install the each components of the field without any difficulties. So in final view of this one is it's like what we are going for the single casting. The same way we can see the surfaces after finishing that one with proper coatings. So this is another one more technology. The same technology, ferrocement technology, we used for developing the sedimentation and percolation septic tanks. And in these cases, what we see is this will be a like a array system, so that each tank will be filled simultaneously, so that we can close that each system, so that it is permitted to percolate. So in meanwhile, the next one will be used for the practice. So this way, what we are aiming to control the septic higher capacity tank requirements. So same technology we used for developing the water tanks. This water tank, which is cast in a single casting using the flowable concrete. So it is a 25 mm thickness, which can hold the water. And the corrosion aspect, if you see the corrosion aspect, the concrete itself is sufficient, having the sufficient strength to hold the steel together, so that steel corrosion will not happen. That is the advantages what we were using for developing water tanks. This is another one more water tank we developed for higher capacities. This is very lightweight concrete, and we developed using the modernized technology also. So this is about the single system for service core utilizations. So considering the housing demand. Now considering the housing demand, so what is available in practice is the brick which is inbuilt into the framed systems. When you are there is any lateral load like seismic or wind, whatever may be the case, so it transforms the load into the bricks, and bricks will initially take a lot of load due to the higher stiffness, and once the cracks are started, so it starts to fall down, and which creates a major issue in the normal building construction. So this only the key factor which is concerned why we can go for the alternative instead of the brick infills. So if you see that the ferrocement infill, if you apply the lateral load, the capacity, because this entire system will be acting as a single system. So till the failure, it is acting as a single system, and moreover, because of the thinner skin, it starts to buckle in the lateral direction. So that is out of plane direction. So normally the out of plane direction here, what is happening here, the cracks which are forming, and then the out of plane direction movement of the brick which fell down, which is not having the enough capability to hold together. But in ferrocement, the case is different, which is having enough strength to hold together. So as a result, the entire system till the ultimate failure, it is acting together, and it is avoids the falling of the any concrete. So this way, the ferrocement is the very high demand composite for the construction industry. So when there is the opening, the behavior of ferrocement is still the same way. After the crack, it is together and it's acting together, so that it is having a higher strength compared to the other construction practices. So this way, the post buckling characterization, and then in the strength characterization, and then combined, that is confinement action. These are all combined together in the ferrocement. As a result, we are getting a very better wall. So this way, we examined using the final software, whatever we are having with us. These models are created using the abacus, and with the damaged plasticity model we used. And then we checked for the different configurations for developing a housing. With opening, that is window opening or door opening, we use and we simulated in the software, and then we integrated together, and we found that so it is like behaving like a same way how that the conventional structures are behaving with a very less cost as well as dead weight. So because of this reduction in the dead weights, normally it will be more advantageous during the any earthquake or any lateral load distributions. Okay, so these houses can be constructed in hours, maybe within 12 hours or within 20 hours we can construct a G+2. It is lightweight to handle, and finally all the components are integrated together so that the entire structure which is acting together during the load transmissions. So similar way, the construction cost drastically comes down when you are using this corrosion construction housing. It is coming under less than 600 rupees per square foot, which is very less compared to the what is in practice now is around 1,500, 1,800 rupees per square. And regarding the durability and ductility, because of the nature of the material, the corrosion which is acting together, so as a single material, and it exhibits a good ductility and good durability during the period. Now come to heat insulation or sound insulation. This is the key factor which has to be think of whether the corrosion can be used or not. So normally these type of structures are it may be useful for the urban, the semi-urban area or rural areas. When the construction is G+1, probably we can go for this type of construction. Otherwise, we will modify later, and I will show that how we modify to consider all these effects in the future. Okay. So the heat control. If you are using a corrosion house, then you can heat resisting can be achieved in nowadays. There are a lot of heat resisting or heat reflecting paints are available. We can go for the painting once in 3 or 4 years. We can get a good insulation for heat. And regarding sound insulations, whatever available with us, we can use based on the region wise, the availability and the region wise, we can go for the mineral wool or cotton or dried agricultural use materials or thinner boards. This can be used. In addition to this one, the EPS sound insulation can be a very futuristic approach. We can get a wall or roof or a desirable characteristic. So considering this dead weight of the structure, the reduction in the dead weight is around 80% of weight will be reduced when you are seeing the corrosion walls or corrosion roofs, which is combined together for a building. So now, here the durability and the strength which is achieved based on the characterization of the concrete as well as the characterization of the steel, and when we are combining together how it acts. Based on this, we are achieving this corrosion structures. Now we will think on the other way, how we can achieve a slab system without a reinforcement. So we thought of this one and we developed a shell, we used shell approach to develop the roof system, and it is developed using a funicular cell. Normally it is called as a doubly curved cell, special cell, vessel curvature cell system. Normally it is combined both positive and negative curvature. That is the system what we use. Positive curvature not only it will compensate the tension whatever it comes there, and then the negative curvature normally it will compensate for the compression. So we are compensating the compression and tension using the shape itself, so that there is a requirement of no requirement of reinforcement for transforming this load to the structure. So this is what the technology we are concentrated, and parallelly we developed the I-beam technology, which is the corrosion concept, and then using these two technology combining together and we developed a corrosion roofs. So these are some of the typical points to be considered when you are going for this conception. Finally, what we can achieve is around 40% of the roof cost saving we can achieve. This is the one. Second way is, if you see that the weight reduction is around 30 to 35% of roof weight is coming down because of this technology. So this is the typical corrosion models what we developed using the SolidWorks, and then from the solid group we transformed, that is imported to abacus, and we modeled this particular shells. If you see this, this is the positive curvature, and if you see these edges, there will be a slight downward curves. This is representing the negative curvature. So the cell itself is having the both positive and negative curvature, so that whatever it is, the results what we are getting from the external loads will be compensated with the shell. That's the way we develop. So this is a typical view of models, and this for the single point when there is a single load. We consider both two-way action as well as the one-way action, because two-way action, one-way action, both are having the application in practice. The one-way application is we can place these indigenous group elements in a row. So similar way, row by row, we can go for construction so that we can easily finish the group within short duration. So that's why the one-way slab is very, very useful. And if it is a two-way slab, you can do a single unit or multiple single unit systems. Then we can go for the four-edge supported system. In both way, we have advantages, and we have to decide that which one is very better for our cases. In both cases, we are having a good load carrying capacity, and this is the typical testing what we done for this. So this shell, what we are seeing is the slab weight. Normally, we are naming this shell as slab here, 1 meter by 1 meter slab, and the total dead weight of the slab is just 60 kgs. So that is the beauty of the system, and the thickness of shell is 10 mm thickness, and there is no reinforcement is provided at the shells. The shells, what you are seeing is here without any reinforcements. So this is a typical implementation. This is ferrocement I-beams, what we developed, and we tested this one. This is very, very excellent ductility characters, and this is the implementation of the shell. The totally we used 32 shells. 32 cells means 32 into 60 kgs. That's all the weight of the roof for a span 4 meter by 8 meters. So this is a typical view. You can see the total cost saving. What we are seeing in here is the 30%, and here the total scaffolding requirements is totally eliminated. So there is only one problem what we are seeing during the erection. If there is any sudden accidental load, like any impact, so that when during the impact, this because the shell is the unreinforced one, and the careless action during the erection will create a catastrophic failure that the shell entirely will fail within a few seconds. But we don't have that. There is one issue. But if you can capable to erect this one, because it can carry a load of 1,500 kgs of load in a square meter, when you are applying a gradual way. But if you are applying a sudden way, even it cannot take a 15 kg of weight. Sudden failure will happen. So considering this one, now we are revising our technology by using the fibers. Now we are doing for the impact studies. Maybe we come with the product within a few minutes. So this is about the technology what we developed using a I section with the particular shell panels in between these. So on the top over this one, the screed concrete will be lean mix of screed concrete will be placed over this one, and that can be used as a roof for the next one. That is floor for the next one. Okay, now I'm coming to the next very important thing. Just to finish within 5 minutes, I will go through the things. So we were constantly now working for developing the precast sandwich panel technology. So whatever the earlier setbacks, what we are mentioned, like thermal comfort or sound insulation, whatever the case may be, that cases, we are coming with another technology. It is a double skin. Instead of single skin ferrocement, we are now using a double skin the ferrocement on both the sides. And then how that integration and what will be the infills, these are the factors which governing the efficiency of the system. So here we filed 2 patents, and we are received our patent numbers for protecting this topic. So this is a typical view of one of the 3D. This is called a standard panel. Normally it is available in the market, which is having the two meshes in the edges, and then it will be integrated together with a three-dimensional, that is a truss meshes. So this truss meshes will be acting together, which connects to the two reinforcement at the edges. So this is what we were seeing in this present day in the market, and then this will be cast as a single element. So the same element can be used for both wall as well as for the roof. And if the structure is less than 4 stories or less than 5 stories, we can directly go for construction without any columns requirement. So the panel itself capable to carry the load, that we will see the later on. Okay. So this is a typical one, what we are discussing. This is available in the market. And the one problem what we are facing is, the cost is around 1,500 rupees per square meter, and based on the density of the EPS, the expanded polyethylene what we are using for the infill. And in the outer skin, only the 20 or 25 mm thickness of ferrous cement we are casting. So remaining the 100 mm, what we are seeing is the just a infill. There is no concrete. So this way we are getting a better lightweight system, which can carry a very good load compared like the solid panels. So when you are applying the load, there is a two ferrous cements, and if there is no integration. So when you are applying the load, due to that the buckling nature of the ferrous cement skin, it goes into the outer plane. As a result, the overall strength reduction is what we are seeing. So for that only, the market available things, they are using the 3D truss mesh. Again, the 3D truss mesh having its own deficiency, like during a higher load condition, the truss will behave better in tension. But the truss in compression will again start to buckle. As a result, the strength characteristics will be coming down. Considering this one, we developed a composite system, which perform very better in both compression as well as in the tension. So this is the technology what we developed, and we, considering the load carrying capacity, this is what we are having is 78 kN, and when we are using a composite connector, the load carrying capacity of this panel is coming under 1.2 kN. That is, if you take in terms of so this is typical results what we are getting. This is for when there is no connection, the strength will be around 60, and if the connection is enhanced, and it will be the double the strength what we are getting here. And these two are for the standard panels which is available in the market. The remaining two are the cases for our new connector what we developed as a composite system. And the load carrying capacity, it is more or less the same, and the ductile performance and other things are similar, and the force buckling behavior of newly developed connector is very high than what is available in the market. So these are the different cases what we are developed our products. So this is failure patterns. This without any interfacial connector. So it will be fail at the ribs and then debonds. As a result, load will be coming down. When you come to a interfacial connector, there is a shear interface connector between the two skins. Then the load carrying capacity is very high, and the only local crushing is happening, and the remaining is everything is it's the unit. You see that everywhere only the local crushing is happening, and the entire system is intact. And this is for the 3D truss connector which is available in the market. So it carries the equivalent load. Only the force to peak behavior, the truss which is interconnecting the two skins are buckled. As a result, the buckling in nature, it will loses its monolithic things. So this is other typical cases for a different thickness. This is without the connector. Here, this case, what we see is only the concrete which is used to interconnect the skins. So, but the tension, it can carry the compression, but it cannot carry the tension. Again, the skin is separated, which is acting separate and which buckles. That's the result what we see. So that the composite connection has to be provided to integrate with it. So similar way, we develop precast staircases using the ferrocement concept, and each and every one is the individual elements, and it just positioned at the location, and it can be integrated together within a few hours. So this is a typical analysis what we carried out for the EPS infilled salvage panels with the door opening. And similar way, this is for the window opening. In all the cases, what we are seeing is the failure is very localized. Everywhere it is localized, so that everywhere even though load is applied here, you can see everywhere the load is distributed uniformly. So as a result, the entire system is acting together, and there is no the isolation of the concentrated stresses will be seen in this structure. That is the advantage. And similar way, when you are combining this one story to other story, normally it will be carried out through the roof beams and the roof slab, and over that one another wall will be placed. So the integration between these the lower floor to upper floor is important. So we carried out the interfacial resistance what we require for transmit this lateral load, and we found that whatever the 12 mm diameter of the bar for the integration is more than sufficient to transfer S4E for G+2 building. Similarly, this is a typical behavior of interface, and this is typical behavior in structure 2-point loading, and we compared with the normally this one way these slabs are useful for the one way slab construction, and we want to develop a two-way slab. So we developed a two-way slab, and this is the cracked pattern. And if you see this one, everywhere the cracks are in the radial pattern, and the crack is what we were seeing here is everywhere through it is uniform. Even though the loads which are we are applied here, the 12-point loads, we are applied a load at the 12 points as a point load. As a integrated system, the lightweight panel which is we developed, it's acting together, and which deforms in a uniform way. As a result, we are getting a very better load carrying capacity, compared to the RC walls, RC two-way slabs. This is taking somewhat higher load due to the uniform distributions. So this is a typical view of the installations. That's the load carrying capacity. Normally, what the load carrying capacity records around 300 kg or 200 kg is the live load, 200 kg is the dead load. But here, the failure is very heavy load is very high, and what is recorded is it will become this region. So this is the high strength region which is available for the ductility. So this way it's benefited. A similar way, we integrated the two stories, then we done the analysis, and we found that it is very much useful for the construction without escalating the cost, and without compromising any strength characteristics, and without affecting the affordability of all the groups. So this way we cast and we transported, and this is the way we assemble the entire structure, which is G+1. We assemble in 28 hours, and we tested for the lateral load. And so similar way we applied the actuators and exciters. We used exciters to find the stiffness of this structure, and it seems to be the stiffness of this structure as well as stiffness of the solid concrete RC structure, both are seems to be the same, and as a result, the composite action what we are getting is the perfect composition, the 100% composite action with perfect integration. So this is a typical view of the structure after the test. Even after the test, we are seeing a very minor cracks everywhere, and there is no major cracks which happen. And as we extended this technology for developing a G+3 building, and it's a typical G+3 building assembled, and we tested for the lateral load. We are using the ropes to pull from the top, and we found that the structure which we are developing with a lightweight roof and wall panels, it's capable to integrate together, and then it's capable to carry the load, whatever the zone 5 recommendations. It satisfies the load conditions well below what is the requirement for the zone. So this way, the technologies are helpful for affordable housing. And thank you. Any questions?
Thank you, sir. That was a wonderful session. Now, if there are any queries, you may clear it. Participants, if there are any queries, you may clear it.
Students, please do interact. Ashmi? Ashmi,
Yes, sir.
Yeah,
Yes,
please,
sir.
please request the students to interact. Sir is just waiting.
Sir, I think there are no queries. Sir, I request you to wait for the valedictory function. It will begin soon. Good afternoon, everyone. I welcome you all to the valedictory function of KSCT sponsored Third International Conference on Innovative Trends in Engineering for Sustainability ICITES 2023. The theme was Sustainable Built Environment. These are our sponsors. I request everyone for a silent prayer. Thank you. Now,
Ashmi, please just wait. Two of our guests also is joining. They have just reached there. For a while, just a minute, okay?
Okay, sir.
എനിക്ക് വന്നില്ല. ഇല്ല, ഏതിലാ അയച്ചാണത്? തുടങ്ങണേന്ന് ചോദിച്ചു തുടങ്ങണ്ടേ? എവിടെ ഞാൻ കേട്ടില്ല ഇതൊന്നും. എന്താ സംഗീത?
Sorry for the delay. The function will start shortly. Thank you.
Ashmi?
Yes, sir.
Yeah, please go ahead.
Okay, sir. Good afternoon, everyone. Welcome to the valedictory function of KST sponsored third international conference on innovative trends in engineering for sustainability, ICITES 2023. The theme was sustainable built environment. These are our sponsors. Let's start with a silent prayer. Thank you all. Now, I invite Assistant Professor Elba Helen George for the welcome note. I welcome you, ma'am.
Thank you, Ashmi. A warm good afternoon to all. I'm extremely happy to welcome you all to the valedictory session of the third edition of International Conference organized by Department of Civil Engineering ICITES-2023. The conference was inaugurated by Dr. Kamal Leskiri Loku, Project Director, Maragola Hyperpower Project, Sri Lanka. He has joined this meeting. Sir, I welcome you. The department is in close association with Dr. Raju Aidla, research scientist, Kumamoto University, Japan. He delivered a keynote session for the conference. Sir, I welcome you to the session. Dr. K.N. Laxmikandhan, senior scientist, CSIR-SERC Chennai, was kind enough to accept our invitation to deliver a keynote session for the conference. Sir, I welcome you to the session. Dr. Vasudevar, head of Civil Engineering Department and conference convener, is the key person behind all the activities of the department. Sir, I welcome you. I welcome organizing secretaries of the conference, Assistant Professor Sahimol Eldos and Assistant Professor Preeta Prabhakaran to this function. I also welcome all the delegates of the conference who have joined from the various parts of the world, other members of organizing committee, staff, and students of the Department of Civil Engineering to this valedictory session. Once again, I welcome you all. Thank you.
Thank you, ma'am. Now I invite Dr. K.N. Laxmikandhan sir to speak a few words. I welcome you, sir.
Thank you. Once again, good evening to one and all. First of all, I would like to present here thanks to convener Vasudev from Talk Institute of Science and Technology, Arakannam. He contacted and he submitted all the data, whatever I'm asking from our side. He made me to easy to get permissions and then coming and participating into your conference. First of all, I would thank him. Also, the convener, secretary, the delegates who are, came and participated in the conference, students, staff members. Good evening to one and all. And this conference, which is having a very nice title, which is very important in the current scenario. So everyone, we are all working to make the engineering structures or engineering materials or engineering concepts for achieving the sustainability of the system. So normally the resources what we are having around us, we are exploiting, and then we are making the non-availability for the future generation. And moreover, these exploitations normally having huge environmental impacts. Considering all these facts, the sustainability nowadays it's considered one of the key phenomena which is necessary, and it is the fundamental engineering science behind everyone. So that's why the topic is chosen in a very nice way. And being a researcher and being the National Institute, CSIR, and we are all always concentrated and we are all developing the product or materials or technologies. It is trying to achieve a sustainability concepts. And in addition to these sustainability concepts, always we are keen to the affordability. Affordability means we are our products normally, which will range from the lower income group to the higher. Everyone will utilize, and then they can take the use of this research outcomes for their benefits. So this way, what we were all working here. After listening this conference, most of the presentations are they are targeted and they are working towards this the single goal, which is most appreciable and which is need for the hour. And I wish the organizers, thank you for your opportunity given to me to present here and then interacting with you all. Thank you.
Thank you, sir. Now, I invite our HOD, Dr. Vasudevar, sir, for the summary of the conference. I welcome you, sir.
Thank you, Ashmi. And can I just present my slide?
Yes, sir. Yes, sir.
Yeah, I'm just sharing my slide. Please stop sharing yourself and yeah. Is my screen visible?
Not yet, sir.
Yeah, is it visible right now?
Yes, sir.
Yeah. Yeah. Is my screen visible and I am audible?
Yes, sir.
Yeah. Thank you very much for giving me the opportunity to summarize this third international conference, the entire 3 days program on innovative trends in engineering and engineering for sustainability, ICITES-2023. So I personally thank Lord Almighty and all the key persons who are contributing towards this conference. And this is the short report of the entire 3 days program. So it is a KSCST sponsored conference which was supported by Abilit as well as ASCE, and it is in association with Institution of Engineers, ICIGBC, and we have a affiliation towards there is universities like there is by Ukraine and also a Chile university. Our major sponsors are being KSCST, ACCT, ASCE India Session, Ramco Siemens, and also Adani Group. This is the overview of my presentation. It consists of the discussions on papers and reviewers, inaugural ceremony, keynote addresses, technical sessions that has happened, concrete cube test competition, poster presentation, and best paper winners. So out of 85 abstracts that we have received, we had received full papers, 59 numbers, of which other state we had 18 numbers, and within Kerala 41. And we had several eminent personalities, national as well as international, as the review panel members for finalizing these 59 papers. So I wholeheartedly thank my entire team and TIST family thank these experts who has contributed their valuable time in reviewing these papers. Once again, I thank each one of them from my heart, and their wholehearted association has helped us to review these 59 papers very meticulously. We had an inaugural ceremony, and the inaugural ceremony was presided by our President Alex Sir, as well as it was inaugurated by Kamal Leshkari Loku, Project Director of Maragola Hydropower Project, Sri Lanka, who has inaugurated and delivered an inaugural address. Sir also has conducted a technical session on the same theme of our same name of our conference, like Innovative Trends in Engineering for Sustainability. And Sir has emphasized on the aspects of water sustainability, construction, as well as energy sustainability. The second keynote address was streamlined online from UK, University of Edinburgh, Dr. Remiza Moideen. Ma'am has discussed on offshore wind energy harnessing system and its future through experimental investigation on advanced technologies and developments. And third address was intended to be of Devdas Menon sir, but unfortunately he couldn't attend the session, and I had taken over the session by a small presentation on good construction practices, which is essential for the young aspirants of engineering. And a few new generation concrete also was discussed. And the fourth keynote address was by President of our ASC Southern Region, President Dr. Pradeep Sivanantham, and Sir spoke about the characteristics of infill frames with short column effects. Today morning, we had our fifth keynote address, and it was an eye-opener and a new topic to almost all the persons who were seated over here and who was listening to the session. It was all about the advanced satellite and UAV image processing and remote sensing techniques with sustainable approaches by Dr. Raju Edla, research scientist of Kumamoto University, Japan. And we also had a technical session by Laxmikandhan right now. It was all about new techniques that has been adopted in SCRC Chennai related to low cost housing. In the technical sessions that we had on the first day 2 technical sessions with the theme Green Materials and Technologies. On the second day, we had 6 technical sessions, 3 each, parallel sessions in morning and evening, which covered experimental and mathematical analysis related to material properties, and also sustainable material in geotechnical design, and a blend of different other topics in session 7 and 8. And on the third day, that is today morning session, we had another 3 parallel sessions in which we had themes related to simulations and tools for energy efficient buildings, sustainability in environment, transportation, and a blend of other papers. And in the day 1, session 1, we had green materials and technologies, around 7 papers, and total number of presented papers is 6, of which the discussions was mainly on the titanium oxide in concrete, optimization and contribution of additive materials using Taguchi method, and usage of plastic waste in the production of bricks and cement composites were discussed. The same day in the session 2, we had the sustainability based application of different materials in concrete, fresh and hardened properties of high strength fiber reinforced concrete using GGBFS and microsilica were discussed. And in the third session, we had analysis of laminated composite stiffened hyperbolic paraboloid hypershells and laminated composite stiffened conoidal shells subjected to impact loads were covered in this session. And in the next session, we had material properties of various projects like epoxy anchor installations, soft story inclusions in multi-story, and numerical model for a deployable bridge using SolidWorks was discussed. Performance evaluation, trackable and non-trackable solar concentrated V-type desalination still were also explored. And on day 2, forenoon session, in this session, we had various methods of sustainable approach in geotechnical design were discussed, and different techniques to improve the strength of soil was delivered. And again, in another presentation, we had soil stabilization methods, utilization of recycled concrete aggregates in stabilizing black cotton soil, and stabilization using nanosilica was discussed in detail. And in a blend of themes, we had innovations used in building construction, especially to improve the performance of building was discussed. Impact of urbanization and natural water recharge due to increase in built-up area, flood mapping using QGIS software, and a study of hydrodynamic energy saving systems for ship sterns were discussed. And in another session today morning, techniques to improve sustainability in building construction, waste management techniques, and effective site management was discussed. And in the transportation engineering sector, we had different payment alternatives, feeder service modes, etc. Methods to improve indoor air quality through natural ventilation and assessment of building comfort in urban areas was discussed in detail in one of the sessions. And we also conducted, this is all about the sessions that we have discussed, vivid varieties of papers from different themes was discussed in detail. And also we had conducted a cube testing competition in which 33 team members have registered and 29 team members has come over here in person and witnessed the strength of their own cubes that they have produced. And the first prize was won by College of Engineering team from College of Engineering Kidangur, comprising the team members Arunima CV, Prijit KS, and Sabin John Sakaria. And second prize was backed by Ilahia College of Engineering and Technology, Hafiz Ayub, Alif Muhammad, and Arun Kumar KN. Hearty congratulations to the winners. We also had organized a poster presentation and exhibition of the posters of various papers that has been submitted by the participants was exhibited here in the campus, and it was an eye-opener to almost all participants as well as students of the campus. And moving to the most awaited thing, the best paper winners. In the theme of green material and technologies, the paper titled Sustainability-Based Assessment of Application of Treated Recycled Concrete Aggregates in Concrete, authored by Tiju Susan Thomas, Chan Karen V, and Dr. Dhanya V.S. bagged the first prize. And second, experimental and mathematical analysis related to material properties, the paper titled Efficiency of Epoxy Anchoring Techniques for the Postponement of Debonding Failure in FRP Strength and RC Beams, authored by Preeta Prabhakaran and Glory Joseph, has won the Best Paper Award. In the theme Sustainable Material in Geotechnical Design, Effectiveness of Using Sugarcane Molasses on Soil, authored by Anjana Viraj and Srija V, had bagged the Best Paper Award. In the transportation and water resource themes, feeder service mode choice modeling, a comparative analysis of Logit model and neural networks, authored by Arun Chandran, Shahim S, Vignesh Durai, and Kirti Sabu, had bagged the Best Paper Award. Simulations and tools for energy efficient buildings, sustainability in environment, the paper titled Post-Occupancy Evaluation of IUK Parameters in Residential Buildings, authored by Mohammad Shamil M and Sahim Eldos, bagged the Best Paper Award. And we sincerely thank Kerala State Council for that is KCSTE, Science, Technology and Environment, and also our key persons, All India Council for Technical Education, Management, Principal, HOD, Dean, Teaching and Non-Teaching Staff, Associating Universities, ASC, ICI, IGBC, IST, and Institute of Engineers India for supporting this conference. Thank you very much. Over to you.
Thank you, sir. Now, I invite Dr. Raju Edla, sir.
So, good evening, one and all. I would like to thank the management, principal, head of the department, organizing committee of the conference for inviting and organizing this conference, 3 days international conference. I hope all the participants enjoyed and had a great interaction with all the resource persons and also in the technical sessions. I would like to wish all the best to all the participants, and very much. I were personally very much impressed with the students' interaction today. So students were really pretty awesome, and they have very bright future. And I once again wish you all the best to one and all. Thank you.
Thank you very much, sir. Thank you.
Thank you, sir. Now, I invite Assistant Professor Sahimol Eldos for the vote of thanks.
Good evening, all. I feel honored and privileged to get the opportunity to propose a vote of thanks in this valedictory function of KCST-sponsored 3rd International Conference on Innovative Trends in Engineering for Sustainability, ICITES-2023. First and foremost, let me convey deep regards and hearty thanks to our management, Turkish Public School Society on this special occasion. In absence, I would like to thank Dr. Alex Matthew, President, Mr. Kurian Thomas, Manager, Mr. KK Matthew, Treasurer, and all the directors of Turkish Public School Society for extending full support throughout this conference. Next, I would like to thank our esteemed Chief Guest, Dr. K.N. Laxmikandhan, Senior Scientist, SCRC Chennai, Dr. Kamal Lakshkiri Logu, Project Director, Morgola Hydropower Project, Sri Lanka, Dr. Raju Edla, Research Assistant, Kumamoto University, Japan, for being with us today in this auspicious occasion. Today, my words are not enough to express the gratitude to our resource person, Dr. Ramisa Moideen, Research Associate, School of Engineering, Edinburgh, Mr. Pradeep Shivanandan, Associate Professor, SRM Institute of Science and Technology, who graced us with their kind words. My special thanks to Mr. Krishnanuni Nair, Senior Technical Engineer, and Mr. Sumesh Murugan, Senior Laboratory Technician, Ambuja Cements, for various help that received towards this conference. At this juncture, we will ever remain grateful to Dr. P. Kishore, South Zone Treasurer, ASCE, and Managing Director of Habilit Learning Solution, for his help and support at various stages of ICITES 2023. I am also thankful to our principal, Dr. Preeti Tekat, for supporting us in all possible manner to organize this conference. I am also very much thankful to all program advisory and technical committee members of ICITES 2023. On behalf of the organizing committee, I thank all the reviewers who join us in ICITES 2023. Words are not enough to thank our chair and co-chair for supporting the various sessions in their busy schedule. Next, I would like to thank our delegate of ICITES 2023. Without you guys, this event was not possible. Thank you very much again. I would like to thank our beloved HOD, Professor Dr. Vasudev R, for his constant help and guidance that radiated a source of energy within us. I would like to take this opportunity to thank my nuclear counterpart, Associate Professor Dr. Smita KK, Conference Secretary, ICITES 2023, who joined hands to organize this dream conference, whose seed embedded in a simple discussion and for a constant guidance and support to shape the conference. I would like to thank Organizing Secretary, Assistant Professor Preeta Prabhakaran, for the support and guidance throughout ICITES 2023. I am very much thankful for all our faculty and non-teaching staff members who are always stand by us and motivate us. I feel proud and thank you for making this event a successful one. I am very much thankful to the sponsoring agency, Kerala State Council for Science, Technology and Environment, Ambuja Cements, AC City Builders, Ramco Cement, ESC Group, and our alumni. It would have been impossible to organize it without their support. An event of this dimension cannot happen overnight. The wheels start rolling months in advance. We are fortunate enough to be backed by a team of very motivated and dedicated students committee and volunteers. I thank each and everyone for the involvement they have shown and the willingness they have expressed to take on the completion of tasks beyond their comfort zone. Thanks to all of you making this program a grand successful. Thank you.
Thank you, ma'am. A feedback form is put on the chat box. Please do fill the form. I repeat, a feedback form is put on the chat box. Please do fill the form. National Anthem. Thank you all.